Hello and welcome again to next in our series of videos. This video will discuss while loops, continuing on in chapter 4. The last video and the last live session we discussed the if statement. If statements use Boolean conditions, the things that are true or false. And in that manner, while loops use the same Boolean statements. They say repeat something until this occurs. The word while and the word until are related. They're similar, opposites, whatever you want to think of them. You can say, repeat this while this is happening. And you can say the same thing in a different way by saying, repeat this until something happens. So we're going to look at those two things here. As an example, let's just start again with something relatively simple. We'll say int x equals 5. Okay, so we have a variable, and then what we will do is create a while loop. So the while loop, again, turns purple. Much like an if statement, you have the condition up at the top of it in the parentheses. If I say loop while x is less than 10, for example, what you're saying here is x starts as 5 and keep going while x is less than 10. And as I said, you can also think of that as keep looping until x is no longer less than 10. So if I print out x, and then I say x equals x plus 1, semicolon, by doing this, I say start at 5, is 5 less than 10? Yes, it is. So go into the loop. Print 5, add 1, add 1. Now, when you hit this bracket, it's going to go back up top. It's going to check the condition again. X is now 6. Is 6 less than 10? Yes, it still is. So print out 6, add 1, now it's 7. Go back up here. 7 is 7 less than 10, and so on. So when you run the program using this little stub, you get 5, 6, 7, 8, 9. It ends on 9 because the order that we did it in, it starts printing the number, then adding 1, then it'll wrap around and check the condition. So when it gets to 9, 9 plus 1 is 10. Is x less than 10? Is 10 less than 10? No, that's no longer a true statement. It's false. So it ends the while loop. It skips down to this next line here. The order of the lines of code inside of your while loop matter a great deal. I printed and then I added. If I flip-flop those, my first number will no longer print 5, it'll print 6. And it'll end, as you'll see here, it'll end on 10. So you really have to kind of think about what you're going to do with these increments, what you're going to do with the output, because the while condition, the Boolean condition, is at the top, not the bottom. That also matters because the while loop may never run at all. What if I started at 15, for example? 15 is bigger than 10. Well, if you put in 15, nothing will happen because the program will get to here. 15 is less than 10. No, it's not. So it skips all this, just like an if statement would. So while loops don't necessarily have to run if the condition starts off as false. Just like if statements, notice that there's no semicolon here. If you put a semicolon here, you're in for a bad time. This is where potentially you could get an infinite loop, a loop which never stops until you stop it by closing the program. If you think about what's going on here, it's going to sit here and sit here. It'll never actually stop. And in fact, I don't know if you can see this, but over here in the top right corner, my diagnostic tools, see how it's using like a whole bunch of processor power, a whole bunch of memory, because it's just sitting here running my program and saying x starts as 5. Keep looping while x is less than 10. Well, 5 is less than 10. There's a semicolon here. This is the loop. 5 will never go to any other number besides 5. it's going to keep looping this infinitely. It'll never reach these lines. So you have to be careful that you don't put a semicolon here. A related issue would be, what happens if you never increment? What happens if you never do that? Well, if you do that, 5 is less than 10, well, guess what's going to happen? You're going to get 5s printed infinitely, which is just as worthless. You have to make sure in the loop that you have some kind of increment that gets you to the terminal case. The Boolean becomes false. While we're here, I'm also remind you that x equals x plus 1. The shortcut for that is x plus plus. Same thing as the language C++. We discuss while loops. Let me close this for a second. We discuss while loops and for loops. They're both repetitions. They both repeat code. They're both loops. But as we talked about in our notes, for loops versus while loops are more indefinite. You're saying keep going until this happens. A for loop, if you remember, is more of a counter. You're saying go in a for loop from 1 to 10. Well, that doesn't necessarily have to be the case. This is counter controlled, 5, 6, 7, 8, 9, and it'll stop at 10. So you're still using like a for loop with a while loop. Let me show you an example of something that's tends to be a while loop, something that we call sentinel controlled loop. So we have this one, let's continue down here. Let me say int num, and we won't assign anything, we won't initialize it. We'll say cin num, and we'll say while the number is not equal to 0, let's say. So what you're saying is type in a number and then loop this while they have not typed in 0. Fair enough. Now, in the while loop, I need to have some way of changing this, because if I type in 5 here, it'll be 5 forever. So I want to put in here another entry, another cin num. Now, by doing this, I would probably be good to put in a prompt of some kind. Cout, please enter a number, type 0 to quit. Again, we call this a sentinel value. You're saying the guardian of the loop, like the bodyguard, the doorman, whatever you want to call it, is this condition right here. You're stopping the loop when you do that value, the type 0. So I type it here. If it's 0, if I put 0, it skips all this. It'll never do it. In here, if I type it, it stops. So let me put this in here. Enter number, enter number. See how it's duplicated? It looks odd, but that's necessary. You have to have something outside and something inside. If I didn't have anything outside, like if I took that out, the computer doesn't know what the number value is. Remember, we talked about that. You have to initialize a value for this to work. I could assign it to something, I could initialize it, but I'm going to be typing it in. So yes, you're going to have something both inside and outside this. If I run it, it's going to say, please type a number. Okay, 6, 7, -8, -4, 9, 1, 0. It stops on 0. It'll keep going over and over and over again until I type that 0. That would be a nice little bare bones structure for doing programs like type in a series of numbers until you get a 0, and it'll find the average of them. It'll find the total of them. Things like that. So keep this little structure in mind as we move forward into some of the programs I'm going to be asking you to do in the near future. The final thing I'll show you in this video is going to be one of my favorite problems from math. It's a very famous problem. It's been discussed for many, many years. It is what's called the Collat's conjecture. and it is a perfect example of when a while loop would be used. Here's the idea behind the Collatz conjecture. You enter any positive integer, no matter how big or small. If the number is even, divide it by 2. If the number is odd, you multiply by 3 and add 1. Let's keep it consistent. And something interesting happens when you do this. I'm going to have you watch a video on Numberphile about this. So if you would like to pause this video and open up the other link that I have in this folder and come back to this, that'd be great. So let's have the hold music. Okay, we're back. Watch that video, come back. Here's what we will have. So I already have num up there, so I'm just going to keep this very easy. I'm going to say for this int n, and I will say cout enter a number for our Collatz conjecture problem. And then we'll cin n. So again, the process here, if n mod 2 double equals 0. So that is the if statement. Is something even, divide by 2, there's no remainder. Else, because we're talking still about ifs and elses, if it's odd, multiply by 3 and add 1. Okay, so what we'll do is we will say n equals n, divide by 2. Of course, we don't have to worry about decimals here because if the number's even, then when we divide, there's still no decimal. Here, n equals 3 times n plus 1. And I want to, what's the conjecture? The conjecture is that when you do this process, every single number, it is believed, will go down to a value of 1. 1 will always be the answer, it is believed. It has not been proven, but it is believed by, they've tried so many different numbers. I don't mean like 100 or 1,000. I mean like they've tried billions of numbers at this point, and they all work. Proof is not example, though. That's why they haven't quite figured it out yet, but we'll see. The video talked about that. So a while loop. Okay, well, if it stops at 1, I'm going to take this code and I'm going to say while n is not equal to 1. And then I'll put this inside that block. So it's going to let me type a number. It'll check, is it 1 already? And then it'll go through this process iteratively until it's finished. What I'm going to do, I need to print it out somewhere. I need to print out the actual value. So down at the bottom here, I'll say cout n. And let's just test a couple numbers. If I run this, and here's my other stuff in the program. I'm going to just type 0 there. Enter a number for your Collatz conjecture problem. So let's try something like 67. So it's going to go pretty fast. 67 is odd, so it multiplies by 3, adds 1. That's even, so it divides. That's odd, so it goes back up, goes back down, back down. And so you can get a sense of it bouncing around, but eventually it's going to converge down to 16, 8, 4, 2, 1. And if you think about y, I mean, those are all powers of 2. So as soon as it hits a power of 2, it's going to go straight to 1 really fast. 32, for example, if a number gets to 32, 16, 8, 4, 2, 1, real fast. So it's a really interesting problem. You know, no matter how big or small, maybe you don't want it to do something that big, it's believed that that's going to go down to 1 eventually. So you're welcome to try it, but that's a perfect example of when to use a while loop. You use a while loop when you don't know exactly when something's going to stop, but you know it will stop. You want to use a for loop, which we'll do later, for when you know ahead of time how many steps something's going to be. Like if you want to say, add these 10 numbers together. That's a good use of a for loop, 1 to 10. If it's something like roll a die until you get a 6, that's a while loop. If you want to do roll a die 10 times, that's a for loop. So it's all about using the right tool for the job. That's all for this video. Thanks again. Take care.